Hello. Yay. Okay, so for people online as well, when I was doing my research, I generated lots of data sets. I was trying to make stem cells move from the blood from the bones into the blood, and I generated videos like this, which were videos of stem cells that I was moving, like the blue ones went faster than the red ones. If I played that video for you now, you could see the blue ones are moving faster than the red ones. That is a good understanding of research. I published a paper, as we all do. I tried to submit the videos, and they said, well, we can't accept 5 megabyte, 20-second videos. We don't have the technology to do that. And I was annoyed because that meant I had to put in a lot more into the paper around, this is, you can see the blue ones are moving at 2 microns per second, whereas the red ones are moving at and it just made it a bad experience for me. So I asked people online, I started making my own files available online. I opened it up to other people, they started making their files online, and we went with this tagline of get credit for all of your research. So the idea here is that everything's becoming more computational. You as a researcher might be generating lots of files in lots of different formats. And my old PI, I remember, at the time, if she had to convert one file into another file format to submit it to a paper, she just wouldn't submit it, right? If it's like supplemental material, we only accept PNG files, and she had SVG files, she'd just say, well, I can't be bothered. I don't really understand what that is, so I'll just leave it. So I think there was this this was back in 2011, 2012, and there's this big need for, as everything becomes more computational, meeting researchers where they are and allowing them to publish their research in the format that they generated. So we have a free Figshare.com. Anyone can go along, upload some files, add some metadata, and publish content. Which sounds good, I guess. You get a DOI. I've broken this again. Click. Yes. I may have to just shout every time I need a slide. I'm not sure.
Is it quicker work now?
I think so. Okay. So everything gets a DOI. We track views, downloads, citations, and altmetric scores. So this is the idea that if you go and do a keynote presentation and there's 20 people in the audience, if you made that available, could you have more impact? If you published a poster at a conference and you get 10 people walk past, could you publish it and have more impact because you want to advance your career, you want more people to know about your research? So everyone knows what citations are, views and downloads. Altmetric is this idea that you can, hands up if you don't know what altmetric is. A few people, okay. So it basically looks at that DOI, that persistent ID, and tracks it around the internet and says, this particular piece on United States commutes and mega regions data for GIS was picked up by 1 news outlet, was blogged by 4. So even if your research is not in a field that relies traditionally on citations, if you're in nursing, for instance, it doesn't really matter how many citations you get. It's how many people implement the practices that you suggested. And so we kind of had around 2010 this idea that the technology exists, that you can move from publishing one format, which is the paper, and having one impact metric, which is the citation, to a whole abundance of different types of content and a whole abundance of different types of metrics. So it's working. With sustainability, I said that was free. We started building repositories for organizations who have lots of different types of content. And we do it for a few different groups. So we do it for the National Institute of Health. We do it for publishers, like that's the Royal Society. We do preprints platforms. I can come into that in a bit. There's a reason why all of these things are similar. And we do repositories for for institutions. That one on the left is Carnegie Mellon. Everything is very computational. It's got APIs. We make sure that it's always up. We do the boring things, is what I say, not to our developers. they think we do the exciting things. But it's more like we take care of the basics for a university, and then it's really about the people working at the university to translate that message. So people can build apps on top of the platform. So it's just modern infrastructure for publishing content. And so, ooh, my screen grab went a bit funny. There is, you have one. You have one here. If you didn't know about it, you have one. The Thesis and Research Data Repository for Leeds Beckett University is up and live. So that has open access theses or licensed theses and the ability to publish data sets and lots of different content as well. So then the question is, how do we get people to use that? Why would people use that? And I'm going to kind of go on that arc for a minute and talk about why should you care? Why does anyone care? Why are we being forced to do this? And just my own kind of sweeping statements on what I think is right and wrong in academia. So I was about to say, don't quote me, but we're being so this is, if we think about open research in general, I just want to highlight that it's very complicated and what a tangled web we weave. And so I tried to think about recently what I thought optimal academic publishing could look like. So you've got all of these different ways in which you can publish content and types of content now. And I thought the real thing we need is fast, open, cost-effective, trusted research, right? How do we get that? And I've got some, so open, humans and machines have ready access to mine and reuse, right? There's a difference between I'm on campus here and I can access the content, and I go back to London and I can't access the content, right? And cost effective, not more than £1,000 per paper. I made that up myself. I think you find it hard to get that with gold open access these days. And trusted in the sense that a peer or a robot has deemed the content to be unbiased and showing what it says it shows. So this was my first attempt at ranking, right? So traditional closed access publishing, gold open access publishing, green open access publishing, preprints, data publishing, and code publishing. Does anybody not know the difference between gold and green open access publishing? Great, I will explain that for you and you alone. If not. So I gave scores, right? How well did you do? And so I'm in the world of, coming from the world of data publishing and making your own copy available on your university repository of your papers. That's called green open access. I'll come back to that in a sec. So I'm thinking, yeah, we're killing it. 3 out of 4 down here, whereas the traditional old way, getting published in Nature, you know, is but not open access. That only gets a score of 1 out of 4. But very quickly I realized that trust here is the most important thing, right? In a post-truth, post-COVID world, trust and integrity of research is more important than ever. So realistically, what good is open if it's not trusted, right? And so just to explain some of these a little bit more detail, code publishing, publishing software, data publishing, publishing files, preprints, that is, here's my paper that I've written, but it hasn't been peer reviewed yet. I'm making it available now because time matters and time is important, right? And then these 3 are all the same. I have written a paper, I'm sending it to a publisher, and they are going to publish it. So I've sent it off to Nature. Closed access publishing means I don't pay anything. My university will pay a hefty license fee that I don't know about and I don't care about because I can still access it. But my mum can't access it, right? The people who pay taxpayers' money for the research can't access it. So we're moving to this open access world. Gold means you pay a fee when you publish it and they open it up for everyone. Green means I have a university repository. I can make it available there for free, but it relies on the researcher doing it who has enough things going on already. Okay, so that was my first attempt at it. There's also other areas, other groups that have their own ways of thinking about things. This is Plan S. It's a group that is pushing for open access content no matter what. So I think they'd say we need it to be trusted, but this came out last week with their Towards Responsible Publishing, a proposal from Coalition S. So quality control processes are community-based and open to ensure trustworthiness of research findings. That sounds good. That sounds like peer review. Great. I personally disagree with peer review, which I could talk about for another 2 days. I think that it's needed and it's necessary. I think the fact that researchers spend time volunteering their time for companies that make billions of dollars in the same time, I think that's the bit I disagree with. So this idea of quality control processes are community-based and open, sure, that's what we have with traditional papers. You peer review them, but there's a lot more stuff. And I just did this, you can see the level of research I've gone into, it's a tweet. But so eLife is a big publisher that's trying to do good gold open access. And so their annual report, they did 2,045 papers, rejection rate of 85%, so high prestige journal they're going for there. And so you can see that it'll cost you £3,150 per article, back of the envelope, not considering a lot of other stuff. That's how much it costs you to publish in a high impact journal. If you think about how, and there's various different paths to get there. And so if you think about open access as a movement, you know, I'm not at a university now, so I don't have access to the content. When I was at a university, they paid a license, I could access everything. I left the university, I don't have access to it anymore. So you can see in like 2019, 2018, the amount of papers that are open access from the start past the amount of papers that are closed access from the start. The amount of papers that are gold open access, i.e. you pay for them, like that model I just showed you, has exponentially grown, whereas the space that I like, the green open access space, has struggled. You know, it's gone up, but relatively it's not going to win that battle, right? And what I think is really interesting, if you go back to my original model of 1 out of 4, 2 out of 4, 3 out of 4, 4 out of 4, optimal academic publishing. So coming from the data side of things, we can make it fast and open and cost effective, but we can't make it trusted. From the traditional academic publishing, papers, closed paper publishing, you've got trusted but not fast open. Yes?
Where would a platform like ResearchGate fit into that? Gold green.
So ResearchGate would fit into green. So ResearchGate, you are saying, I am making my papers openly available. Instead of making them openly available on the university repository, I'm making it available on what is essentially a social network.
And of course you can do both, you can put it in Symplectic and on ResearchGate.
Exactly. The complications where that come in, speaking from a place, remember the free Figshare, you can publish stuff, and we have rules on what you can publish, but we're a 50-person company, so if you start publishing stuff on underwater plasma physics, it looks academic. Is it nonsense? You know, right? So, and the Daily Mail will come along and cite that as a source because it's got a DOI. So there's problems in that space, which is the thing I'm trying to raise here is I don't have the answers, more questions, but if you're going to say £3,150 an article, gold OA, you're looking at, since gold OA became a thing, we're looking at about 16 million articles. So we're looking at £50 billion has been spent on that. So you can see why this is doing well, because certain companies are very good at optimizing that cash cow now. But I'm not saying it's a bad thing. I'm saying that, again, like peer review, the bad thing is the exploitation of the system, right? And my question is, if you're going to spend £50 billion to make the one that has trust, open, fast, and cost-effective, you're never going to get cost-effective there, surely. But could we spend less money to make data trusted or preprints trusted? And again, I don't know. I haven't done that maths, but I think it's an interesting one. And so within that, you also get this paper mill system. And so this is one of the reasons why people say, why is open good? If you have all of the information openly available, then you can make more informed decisions. I used to, at the beginning of Figshare, when I said to people, back in 2011, I was wild. I was like, you should open everything, open all the things, right? There is no good reason why you shouldn't open things. And then I learned that I was wrong, and there are good reasons why you shouldn't open all the things, patient confidentiality. If you're publishing a data set on the geo coordinates of the last known white rhino, the poachers are going to go and get it, right? So the European Commission has this idea of as open as possible, as closed as necessary. And I used to get it a lot, if you're getting researchers to make the data available, what if they just make up the data? And I was like, well, what if they're doing that now? Right? You have no idea. There's no, at least if the data is open, you can start looking at it and say, there's something called data forensics, like humans often end data sets with the letter, made up numbers with the number 8. So you can start looking and saying, oh, does this look made up? But if you're not making it open, you don't. And another area is paper mills. So if you are working in a field, China used to have this. The part of the explosion of open access was, they said, if you are funded as a Chinese researcher and you get published in a journal with an impact factor over 5, we will give you a monthly wage bonus. If you get published in Nature, you got like a year bonus. And PLOS, Public Library of Science, had an impact factor over 5, exploded with Chinese content, struggled to keep up. And now you have this paper mill problem. So Digital Science, our parent company, started looking into this and saying, can we scan the papers and start looking for markers of trust? The researcher history, organization identification. Do you have an ethics statement? Do you have funding statements? Do you have data availability statements? Can you just look at things and start questioning whether these publishers are actually acting in good faith? And you can. So you can run it across. It's good, but it also opens this question of, again, show me the metric and I'll show you how I gamify it, right? And so MDPI is a publisher that publishes a lot in gold open access. Some people raise questions, does brilliantly on this. They're a modern platform. They do very well. They do better than Elsevier on this, right? So this is, I promise I'll get to data, by the way. I know it's data at the beginning, but this is just kind of like setting the scene for the landscape. So what I find really interesting in this kind of trusted space is, if you go back to the year 2000, this is the explosion in the number of publications, right? Because publications are a career tool. In order to advance your career, you need to publish. The more high impact publications you have, the better you'll do, or just the more publications, right? So we were under 2 million papers a year in the year 2000. We're now about 7. Again, going back to my thoughts on peer review. So there's not 3.5 times as many researchers now than there were in 2000, but they're doing 3.5 times as much peer review. Some universities say it's part of your job, some universities don't, so you just do it out the goodness of your heart. And so this is the cumulative outputs once you've got publications, data sets, and preprints. And the reason I've put it like this is because we now have 2 million data sets a year. So coming back and saying, hey, researchers, I know you already have 3.5 times the amount of peer review. Can we just put data set checks in your world as well, so you can check that they're well done? So it's a problem, right? How do you check that the data sets that are being published are good? So this brings us to fair data. What is it and what is the point? Can anyone tell me what FAIR stands for in this context? Nope. So FAIR is findable, accessible, interoperable, reusable data. And it's quite a dry, like this paper's quite dry. I know, I feel I can say that because I know a lot of the people, but it's, it's saying, if you want to make academic data useful, this is what it needs to do, right? And it's a bit vague. It's a bit fluffy, but what it's really done, this came out in 2016, what it's really done is it's made it very easy for nation states and governments to come out and say, yeah, we need fair data. The Chinese interpretation might be a little bit different to the South African interpretation, but it's kind of like we were all just heading in different directions, and now we're kind of headed towards that door, right? We're all moving in the same general direction, and that is fair data. So findable, accessible, interoperable, and reusable for humans and machines. Why bother? Why care? Data is expensive, right? If you're a funder and you say, here's $20 million to do some research, which is pretty normal. And what you get at the end of it? Well, we've got these 5 papers. Fantastic. We got CRISPR out of it. Great. But show me I saw a CRISPR book. Yeah, CRISPR. But what else have we got out of it? Can you see the methods and what you've done with the code and the DNA in order to get there, right? So this is going back 2013, Obama. Making the human genome was openly published. It was a private versus public battle in 2001. And it's very easy. It's very easy to talk money, right? For every dollar invested in the human genome, $140 back to the American economy. Simple. So what do we need to do with data in order to make more money for the American economy? And even idiots understand this, right? Trump was on board. He was like, sure, yeah, money, sure, it's speaking my language. But the European Commission, this is a global thing. European Commission could save 10.2 billion per year by using fair data. Again, wishy-washy, but it means that of global funders, this is a global thing that's happening. Funders are saying, if we fund you, we expect you to make your data openly available. And this is the first, why is this important? Because there's researchers at this organization who will be funded and need to make their data available and have no idea what to do. So 52 funders on Sherpa Juliet, which is a JISC project, require data archiving as a condition of funding, and a further 34 encourage it. The big one this year is the National Institute of Health, the biggest funder of life science research in the world, 50 billion a year, is mandating open data. If you are funded by the NIH, when you publish your paper, you have to publish your data, right? So that came in January 23rd this year. We've got inundated with questions. I felt like a librarian for the first time. It's like, what are we supposed to be doing? It's like, can you go and speak to your librarian in your university? So why is it important? This is, so as I mentioned, Figshare started 2010, 2011, and this book had just come out. And this shows you why data is important for the funders and for humanity and for research, right? We're not going to be discovering penicillin again. The low-hanging fruit on discovery is done. So this is a book that came out from Microsoft Research. A guy called Jim Gray wrote it, was the lead author, and then disappeared on a boat sometime after and was never seen again. Sadly. But so in 2010, just more than a decade ago, he came up with this idea. It's the 4th paradigm, which is we've had 4 phases of research and discovery, and the 4th paradigm involves the need to share data, and it's just the computers are going to come and eat all of the information and provide new knowledge for us, right? Which in 2010 was insane. We'll have the literature, we'll have the derived and recombined data, we'll have the raw data. This is figure 3 from one of the books, right? A huge increase in science productivity, a huge increase in scientific information velocity. It's like, if we build it, then they will come. The internet can unify all literature and data. And it's really about this idea that academia works. We got the COVID vaccine. We still have research that builds on top of work that's gone before. Drug discovery is an easy one to explain because my mum, who's not an academic, can understand this. This is the idea of, if you build on, this is how long it takes for finding or a drug discovery. And, if you have these 3 research groups working on it, and The old way of working was you publish a paper and then somebody emails that person and says, hey, can I get the data behind this so I can build on top of it? All it took to stop that and therefore drive this way. And in one example, cost lives and the easy example, is just not reply to that email. You don't even have to be active in it. You can just be passive. Data doesn't get shared. Whereas if you mandate that everyone has to make their data openly available, then there's no ways to be passive, right? You just have to make it openly available. So with data sets, we build, the way I say it is we build infrastructure that allows researchers to make their data fair. Does that mean that their data is fair? No. Because if you go to the free version, people come along and upload a data set, publish it, and they call it data set. So is that findable? Well, not really, because if you go to Google and Google data set, that's not going to come up, right? Because people aren't educated in metadata and descriptiveness, and this is the gap we need to fill. If your data is movement of mesenchymal stem cells in this medium, that should be the title, so people Google it, they find the data set, it's findable. And so I say data sets and Figshare is fair for humans, but only findable and accessible for the machines. And you need very descriptive metadata. You need somebody to tell you this is the license and things like that. And so if you have librarians in the system, they can make it findable, accessible, interoperable, and reusable for humans and for machines, which is where we need to go. Because the vision of that fourth paradigm involves homogeneous, consistent, high-quality metadata. And in publishing data, you have kind of this dichotomy at the moment where you can say, I want to publish my data set, where should I publish it? And I did genetics and stem cell biology. So if I have a genetic sequence, publish it in the in GenBank, which is a government-funded genomic sequence database, right? So that's the geneticist sorted, right? But I was a geneticist and I had all these videos of stem cells. Where do they go, right? And so the answer is a generalist repository. So you have highly descriptive one file type databases, and you have kind of catch-all databases. So the next level up from there is the university repositories helping you describe your data better. And then I think we'll fill this gap of cancer repositories and things like this. So you have metadata fields like species, which you don't have at the moment. Because with the free Figshare, we can't say to people, upload anything you want. And then, you know, a geologist uploads some rock data and it says species. You just give up. It'd be confusing as a metadata field. So we've done things where we've done some work with the NIH where researchers submitted data, we checked them and tried to improve the metadata, and they were published on an NIH repository. Boring slide. If you have more metadata, you as a researcher will have more impact because more people will find it, you'll get more downloads. We don't know about citations yet, it's too early. What we do know is that if you, again, 10 years ago we didn't know this, if you were a researcher and you were publishing a data set, a lot of people say, well, I don't want to publish the data set because then that gets cited and takes away citations of my paper, which is my career instrument. On 500,000 papers, if you link your paper and say there's a data set available in a repository here, like your university repository that you have, it's associated with, on average, a 25% increase in citations to the paper. So people think it's going to dilute their impact. It actually amplifies their impact. Again, just hypothesizing that, well, if I've published my paper and the data is available, people trust it more. So they cite it. 500,000 papers, not small n numbers. So we try and understand, in saying hypothesizing, we try and understand why people do what they do when it comes to publishing data. So we've been running this survey for 8 years now. The 8th one came out last week, so it's very much in my head, and so I will show you some results from this on why researchers are making data available, why they won't, etc., etc. We do it with Springer Nature largely for reach, because people tend to fill in Springer Nature surveys more than they fill in Figshare surveys. Probably because they think it means that they're on a mailing list and they'll get thought of nicely when they submit to Nature. Is there someone in this room who is in the library who is supposed to be helping researchers with data? So this, Leeds Beckett is doing better than a large majority of organizations, because these are the like 4 or 5 take-home messages from this year's survey. You can go and find it. It's got lots of data. The Chinese Academy of Sciences is taking it and releasing just the view from China based on the data, because they want to do that. But do you have access? Support is not making its way with data. Almost 3/4 of respondents have never received support with making their data openly available. So 75% don't. And only 1/4 have some support based in their library. And again, what areas do you feel you need help? So data management policies and finding time to manage my data is on the up. Finding time to do anything is on the up, right? Because there's more things to do. So this is a pretty obvious trend. What's really interesting here is copyright and licensing of my data. Just year on year, if you go back the 8 years, people still don't know. If I publish my data, there's things called Creative Commons licenses. What does that mean? How do I make sure someone cites me? During or after, this is quite messy, during or after data collection, do you curate or prepare your data for sharing? No, we do not have the resource to do this, but we would like to, right? And I don't know where that resource is going to come from, but there is a problem there. One size does not fit all. This year we tried to say, okay, it's been very easy to go out and do talks like this for a decade and just make sweeping generalizations. Researchers want more credit, they don't know about copyright. And it's like, well, surely there's some nuance in the detail here. Surely it's not all the same. And so this year we looked at different demographics. Awareness of data management plans by country. So this is when you go to get a grant, you have to submit a data management plan, what you're going to do with your data now a lot. UK comes second. Ethiopia comes first. We'll come back to that. Japan doesn't do well. We'll come back to that. Would you support a data mandate in your country? As I say, we've been doing this survey for 8 years. In the beginning, I thought, no, people wouldn't support a data mandate. But actually, if you ask researchers, they don't want to do it if no one else is doing it. If I'm forced to make my data available, but my peers aren't, then they have an advantage over me. They can scoop me, I can't scoop them. So if you make it, everybody has to do it, sure, I'm on board. But you actually see differences. I don't know if they're cultural. I don't know if they're, my hypothesis was if the funder says you have to do it in your country, then you'd be on board. Japan, again, not really on board compared to other countries. Japan's second biggest funder has a data mandate. Yeah, Ethiopia again, fully on board. Open to openness, right? So making research articles open access should be common practice. So these are, what do you think should be open? And there's 4 types: papers, data, methods, and the 4th one is publishing a preprint should be common practice. And again, pretty much every one of them has that order. Papers, yes. Data, yes. Growing. I'm sure if we do this year on year, you'll see a wave of it growing in each field. But you do get subject-specific differences. Mathematics loves preprints compared to other subjects, things like this. So if you're in the library, you can cater your messages towards different researchers. I think that's something we didn't know about before. Motivations for sharing data openly. Again, similarities, but there's differences. The biggest ones are always citation of my research papers, full data citation. I like that business has financial reward. I like that. It's the right people in the right subject, right? This one we argued with Springer Nature on because they thought that it wasn't important, and I thought it was important. It's very messy, I appreciate. But this is are later career academics really opposed to progress? And I think this is a general concept that I've heard about over time. There's a Planck's law about it, but that, in order to advance to make societal change in academia, you have to wait for researchers from a former generation to stop being researchers. It's not true. It's not true. If you look on year of the first publication, I mean, there's variance, but there's no trends. Or what motivates you to share your data based on when you first published the paper. There's variance, but there's no trends. It's not like the more established researchers don't want to do this. It's twofold. It's a double-edged sword. It's like they have the same reasons why they would do it. They have the same reasons why they wouldn't do it, and they are very confused about things like copyright. So it's just you just treat everyone the same on that level. There are some nuanced differences, right? Who lists the cost of data sharing as something that puts them off data sharing? I love this one because it's the PI, the person responsible for the money, is like, I've got to control my budget. Where are you taking more money from, right? And undergraduate researchers who are just like, I have no money. Do not bring money into the conversation. And we started talking about AI because why not? It's the zeitgeist. Plus, if we do it every year, we can then next year say, wow, loads of people are using AI tools for data collection, processing, or metadata creation. Same answer for everybody. 51 for each three of those, 51%, more than 50% said, I know about it, but I'm not doing anything. So I'm sure that'll change over time. And credit is an ongoing issue. Nothing's changing here. Funders are saying you have to do it. Nothing is for 8 years straight. The vast majority, 6% of researchers say we're not getting enough credit for sharing our data, and they would be motivated by more citations to research papers, more citations to data. So I'm going to swing back to the kind of good news and why it's important once more. So, and then I'll finish off. So I mentioned about this is the Office of Science and Technology Policy from the White House. America's easy because they've got the biggest R&D budgets in the world, so it's easy to highlight them, even though it's a global thing, because it's backed by lots of dollars. And so the NIH said you've got to share your data, and they said if you haven't got a university repository or you haven't got a subject-specific repository, use one of these free generalist repositories, which is all good, but they have a word for it. It's co-opetition, right? I don't consider these, we're there. I don't see these other organizations are competition. Some of them may. And so the NIH said, we're going to fund you all to work together. So if you have a research organization identifier, if somebody from Leeds Beckett published a data set on the free Figshare or on Dryad or any of these other repositories, if you all use the same identifier schema, then someone at the library can just go to an aggregator and say, give me all of the data sets from my organization, right? Otherwise, that's not going to happen. And the reason I'm bringing this up is because I am co-chair of the Data Citation Working Group for the NIH, which means they want to start rewarding researchers for making their data openly available by tracking metrics. Citations is the obvious one, but if we count them differently at different repositories, then how do we compare apples to apples? So I know that this is coming. They're desperate for it to happen. And career progression based on data publishing and the metrics around it is something that you will see and you will have, because Leeds Beckett has a repository system for data that's already set up to do this. I can assure you that any new policies come in, we will put them into the system for you, and you are ready to go. Or else what? If I don't make my data available, what are you going to do to me? And a sister organization called Reperta came out with the State of Trust and Integrity in Research report. Those trust markers I was referencing before and saying we can test how publishers are doing, you can also spin that the other way. And you can say, for the government and funders and their policies, how are the people you fund doing if you said in your data management plan you were going to make your data available, did you? You can check for this now. So as well as the carrots of you can have more impact, the funders are going to start checking that you're making your data openly available, or they're going to start taking your funding away from you. So there are tools to do this now. That report looks at where people are making their data openly available. And this is for the generalist repositories that I just highlighted. This looks at 5 funders from 5 different countries: China, Gates Foundation, European Commission, NIH, and BMBF is German. Everybody says repository is the most likely place they put their data in across all of these papers that are funded by them, by these funders, except for the Germans, who have data available upon request as their number 1. So I like calling them out for that. But it's promising that we're heading in the right direction. The thing that concerns me is, as I mentioned, things like the generalist repository Figshare solves a problem for people who don't have a university where they can publish stuff. We don't want stuff ending up in there when it can end up elsewhere. So these are all up and to the right. You saw that graph about how many data sets being published every year, something that we need to work on. Okay, you remember this book. Why should I care about data publishing? You're going to get credit for it. They're going to punish you if you don't do it as a researcher. You already have a solution at this university, so you can shout about it. But if we come back to this idea of a decade ago, if we just make all of the data available on the internet, then we will be able to make that big leap of the low-hanging fruit is gone. At what point are we going to get the machines to create new knowledge for us and drive us further, faster? It's happened. So DeepMind from Google is their AI company called DeepMind, based in London, bought by Google. They famously beat a game called Go, which was very hard to do, apparently. I have no idea. This seems harder. They took all of the protein folding. Protein folding is very important. Apologies if I get this a little wrong for those who are in the subject. But protein folding is very important for drug discovery. If you've got a drug and it won't bind to that protein, or your protein is a drug, how do you get it to bind with the receptors? So the way in which we find out the shape of proteins is using crystallography. Costs about £50,000 a pop. We've been doing it since the 50s, and we had something like 12% of all of the human protein folding structures mapped out in 70 years at 50 grand a pop. So DeepMind took all of that data, got the machines to eat it and spit something out, and now we have 100% overnight. So this is complete game changing for protein folding structures. I think they're going to win the Nobel Prize for this. They've already won the Breakthrough Prize for this. That was last year, and then so this is September 2022. September 2023. They've done it again with something called alpha missense, which is predicting genetic diseases. So that we are at the point where that fourth paradigm of research, can the machines feed us new knowledge, is already happening. And the big question for me to end on is, we're going to get this. Machines will help researchers create more fair data. The machines will consume the fair data to provide new knowledge. The researchers leverage the knowledge to gain deeper insights in their respective fields. A nice virtuous cycle. There is still one step we need to get past, which is, what is going to happen first? If you go all the way back to my point around trust, machines eating data on the internet is pretty easy. They can break laws doing it. They could go and just get the whole of Sci-Hub and take all of the data, all of the papers in the world, right? Machines don't care. But we're going to need to get the cleaning done first before we turn it on and end up with machine learning algorithms like my Spotify playlist, which doesn't find me anything new. It just finds me more music of the same exact type. So if any, I'm just getting smaller and smaller and not bigger and bigger. And so fair data is important because it will literally change areas of research and the way in which we discover new things. We want the machines to consume and generate the new academic content, but we also want the machines to be cleaning it, or at least the humans to help clean it or educate the researchers in the short term. Who would researchers be willing to receive support from in helping reviewing, curating, and preparing their data for public release? More still say publishers than institutions. I feel that's a problem in that institutions have the support, publishers generally don't. And they go there, they think it's that because that's where they disseminate their content already, right? So that needs to change. And I just wanted to finish with Amy's post where you have been doing some. Last year I conducted research on a researcher's knowledge and support needs regarding open data. 57% hadn't used it. Researchers said they needed further guidance and support, practical guidance on how to make it open, and a named person service to go for support. And that's what you're actioning, which, as I say, puts you leaps ahead of the vast majority of organizations, but it's not going to be easy. So that's everything from me. Happy to answer any questions if there's any time for it. Thank you.
That was brilliant, Mark. Thanks so much. Open to questions or comments.
I also wait. I have a quick question around metadata, because I'm quite meta myself. So do you think the approach to data and the veracity in it involves the same skill set as categorization and metadata? Because I find naming conventions people really struggle with when it comes to, it's like when you mentioned an SVG, I know that's a scalable vector graphic because of my background and stuff, but do you think that there's like maybe a digital literacy disconnect there based on that?
Huge. And the problem is, I mean, it's been good to do an experiment in the free Figshare came along and people had a place to make data available where they didn't before, right? I didn't, so I built something so people have. Now there's other places they can. And the problem is we tried to build it metadata light so that people, you know, you don't get to the license field and there's 50 options. And you're like, well, I don't know what this means, so I'm scared, so I'm going to stop. But as a result, you end up with lots of poorly described content. And now the question is, how do we make it easy for researchers to put in good metadata without knowing they're doing it? And there's been an interesting thing happen recently with kind of crosswalks. If you come along and say, I want every bit of metadata from Leeds Beckett data repository, and I want it in this particular schema. The old way of doing that is really hard. Like someone in our team's got to do a crosswalk, and that field means that field, and there's a bit of human error. If you give that to ChatGPT, they do a pretty good job, but it's pretty good enough. So I think, I also think that checking data is not the same as, it's not peer review. It's exactly what you're saying is the metadata good enough? Not, is it novel? Can I reproduce it? Level one is the metadata good enough? And if we can get there, I think you're halfway there.
So I don't know if it's just me being old or whatever, and being quite analog, but most of my research is qualitative. Okay, so an awful lot of this stuff seems to be positioned for the more quants stuff, the empirical sort of scientific research. There are just as many insights from qual as there are from quants into the human condition. Are there repositories, etc., out there for qualies like me?
Yeah, it's interesting because different fields have different. The thing I was saying this before. The thing that I ask people is, do you generate files? What are your files? Right? You work on a computer probably. You might note down things in a Word document. You might do surveys. You might do videos with interviews with people. You might do other types of research. Whatever your files are, that is your data. And we find that there is whenever we start working with the university, you always go in thinking it's the geneticists or the ecologists who need it. And then you'll find somebody who's doing the arts and humanities who's like, I have 10,000 puppets that I've digitized that I need to make available somewhere, because there's nowhere to make that available. And so you often find different subjects take off. But what I think the next step there is these subject-specific repositories. Not to the point of protein data bank, that file type. Just if you're generating that file type, put it here. I'm talking about, yeah, qualitative research for this field.
Consumer behavior, 70% of the research that's done at the consumer behavior, which affects everything,
yeah,
is qualitative.
Yeah.
You know, and it seems to me there's a screaming need for these sort of repositories. But then it comes back to what you're saying. Should you include your videos, your audio recordings, your transcriptions, or your thematic analysis, or you know, and I wouldn't have a clue. First time I heard of FAIR was when I was applying for funding. That's I applied through Horizon and then through Levership. Both times the FAIR thing came at me. And, you know, but the quality thing does seem to still be an issue.
Well, and it's a question of the NIH, which I appreciate is life sciences, has a nice solution to answer that question for their researchers when they say, well, you mean the raw data that comes off the machine, my analysis of that data, the final spreadsheet behind that graph, and it's whatever I need to back up the findings of that research. And if you can back up the findings of that research with these 5 files, but not these 5 files, then it's just those 5 files.
If you do that, isn't there then a danger that we move into behaviors such as, you know, p-hacking, you know, all the questionable research practices, because we are able to select what we're putting into the repositories?
Well, I mean, again, comes back to what's stopping us from doing that now. You could just make up the data. If we were going back to the political people I had on the screen, if I was in North America where they have the 2-party system and I said, votes being counted, I won. It's like, well, can we see the votes from every state? And you say, no, that's what we have in academia today. Is you can just make it up and hope that people believe you. Whereas if you have everything openly available and everything transparent, then they can still do it, but it's just a little bit better. And you will have problems, I'm sure.
Does your system have sort of embargoes built into it? I'm thinking like I've got 5 doctoral students and some of them do quants. They're going to produce a large data set. But as you know, you do your thesis and then you do your salami slicing. And then you 2 or 3 papers out your thesis. Now they might not want to put all their data set out there on day 1, right? Because they, you know, we all want papers out of our people who've got PhDs, you know, and we all do a little bit of salami slicing.
It's a career
is
tool.
there a sort of embargo facility where you can log the successful doctoral candidate can log their data set and say, yeah, it's all there, but I still want to get a couple more papers out of it before everybody can access it? Is there that sort of facility?
Yeah, there is exactly that. So it's got various ways to do it. When I say we do the boring stuff, this is the kind of stuff we do. So you can publish it and just say, here's a metadata only record, we're never going to make that file publicly available. You can say, here's the metadata, you can cite it, but the file is hidden and you can get in touch. There's a form if you want to, or you can say, I'm going to delay the publishing of the files for 2 years, but you can still discover it on the internet and see that I've been working on that, and you can get in touch with me if you want. And we have it with IP ranges. I want to publish just the amount of edge cases is crazy. The IP range one is because I know you've got it for theses, dissertations at a university. They gave away all the copyright to ProQuest, so academics at the institution can read the papers, but I can't. So if you just publish all the theses, dissertations and theses to the IP range of the institution, then we do that as well.
But this, if I may interject, that does come back though to the incentive structure, because I don't think the point should be to publish as many papers as possible. The point should be to do good research. So actually, I would not want to incentivize our academics to publish as much as possible. So I think we need to also challenge some of the assumptions behind and the incentive systems.
The incentives. I mean, for me, it's always you have to play the game. From being at Digital Science and seeing that we have this like pipeline of organizations that want to come along and they say, if academic publishing was invented today, this is what it should look like. It's like, yeah, but it wasn't.
But then you get the sort of deontological problems that you mentioned earlier on. Those that can afford to pay £5 to get a paper published can. Those that can't don't. You end up with the two tiers.
I told you we'd have more questions and answers, right?
That two-tier system in itself go against the whole notion of fairness, accessibility, sustainability, and everything.
So yeah, we think about this internally with the idea that if a Leeds Beckett researcher can go and publish a data set at a place where they have librarian support to help them do it, and instead they go to the free Figshare because it's got lighter metadata and I can do it quicker, it still ticks that box. That's bad. So why does the free version need to exist anymore? We could just take it down. We could keep all the stuff that's already been published up, but not allow anyone to publish, and then, well, what about people who don't have a university that can afford to pay for it?
That's too many questions.
I was going to go for a second.
Sorry.
No, I was going to say, so with the new EU AI Act, so it's in like the 3rd revision, do you think the protectionism in it will work for something like this?
I'm not familiar with the EU AI Act.
Well,
The
EU AI Act.
Oh, okay, yeah.
The whole thing. But essentially, the perspective on it is always economic because naturally that's what the EU does well.
Yeah.
The bloc.
Yeah.
But I find there's kind of two schools of thought when you look at the protectionism within an act like that. So because it is heavily political, there's the functionality of it, which is process features like the data repository, but then there's the experience of it. So do you feel like, how do I wrap it up without having essentially with the functionality that you offer, do you feel like that will impact the experience to support researchers feeling more confident? That's where I'm going.
Yeah, I mean, I think
based on regulation, that's kind of what
I think what you can get to as well is the point of this also was true in kind of the IP thing is, I just want to stamp it and say we've got some really cool stuff over the years, which is just people wanting to be first, right? So there's like a thing called nanopore, which is like this little mini. It's like a UK success story in genomic sequencing. It's this mini genome, and we have the first ever nanopore sequenced on there because they just want to say first. And so I think when it comes to provenance, at least you can say, I published that data set at Leeds Beckett. We know that using the bots that you've been scraping it for OpenAI / Microsoft AI now. So there is the tool that allows you to have that provenance. But I think there's other things that will be solved very quickly in that the speed at which AI will accelerate through things like, the phantom hallucinations on citations. I think that's going to be solved pretty quickly, right? Because we at Digital Science have databases where we can say, that's not a citation, that's not a reference, that's made up, So I think it will help with provenance, but experience, I don't know. I don't know if researchers, it might be too far away in the researcher's head.
Yeah. Thank you.
In your experience, when you talk about the FAIR principles and trustworthiness, where should we put our efforts in terms of developing our colleagues?
So I think the biggest hurdle is going back to this descriptive metadata. It's like, A, are you doing something? And B, are you adding descriptive metadata with that findable, accessible? Because the technology can look after everything else. As I say, if you need that metadata schema to be exported in a different way in the future, the technology stack can look after that. We can't go back and ask that person to put in more. We can go back and ask that person to put in more metadata, but they probably won't. They'll have all of the information then. So I think education around created a dedicated email support address for research data inquiries, increased guidance and short videos. So say how you do these things and how you make it. You're already doing the right thing. And as you mentioned, the first time you heard about it was you were applying for a grant. Yeah. And so it's making sure that loop is, I know there's someone at the university who can help me. And it's unfortunately a lot of it is just repeatedly pumping out the same message, which is competing with things like, what's an orchid? Why do I need this?
My other question was in my field, I study corporate governance, and a lot of the research is based on private databases, so Bloomberg, Boardex, and so on. which has been a problem, I think, for a long time, because institutions that can afford to shell out for those databases. What's the relationship with data providers like that and something like Figshare? Because obviously, if I buy a set of Bloomberg data, I wouldn't be able to put it into.
No, and we do. I mean, I'm amazed at how well the copyright system works. Because we get, if someone puts up something they shouldn't, we get told about it pretty quickly. Yeah, you get an email. But so I think it's interesting. If you ask researchers why they make their data available, or what would motivate them to make their data available, number 2 is public benefit. And just my own personal opinion as a former researcher, I might answer that. Whether that's actually true, I don't know. And so you have pharma and organizations that you were just referencing there who suggest that they're going to be better at sharing data between groups, but whether they actually will is another one. Pfizer's a client.
That's also shocking, quite frankly. Yeah, so I once had to buy a data set and then found out it was
Very good. Yeah.
Other questions? Well, I think you've given us a lot to think about. Absolutely brilliant, Mark. Thanks so much for coming along.
Thank you. Thanks for staying.
All the interesting questions. Thanks for coming along, everybody. Oof.
Yes, there's some Figshare takeaways over here, including socks. So please.